Hello, today I will be presenting my experimentation and results for Physics 2211 Lab 4 on oscillation. This experiment aims to estimate the oscillation of an object attached to the end of a spring. The oscillation of a spring will be tracked and calculated from a video of a mass attached to a spring. The oscillation of the spring will then be estimated in a program which uses only physical calculations. This experiment looks at multiple physical principles, including velocity and position updates, net force, spring force, and non-constant forces. Here we have the spring force equation, which uses spring stiffness, relaxed length, extended length, and direction. Here's the position update and the velocity updates, and then this is velocity update with acceleration expanded, which will be used for the calculations. So here we have the experiment. This is the video that was used. The initial conditions, we have the weight was 0.402 kilograms. The initial time was 0 seconds, and the initial velocity was 0 meters per second. The initial position was negative 0.11 meters, negative 0.648 meters, and 0 meters. The force of gravity is negative 9.81 meters per second squared. The spring stiffness of the spring was calculated from the video to be 6.83. And the relaxed length of the spring, also calculated from the video, was 1.23 meters. And here is the oscillation that was taken from the tracker video. So here we have the code. This is our T and our delta T. The delta T was chosen because it is a multiple of 10.5, which was the frame rate of the video. This was the mass of the ball, and then here's the position and velocity put in. Here we have the other values I just talked about, and then this is where we start calculating the values that go into the spring formula. And then here we're starting to calculate the forces, and then this is the loop that will give us the oscillation in our results. And then this is so here we have the velocity update formula, and then the position update formulas. Like I said, this was what was going to be used, and then this is the spring force formula. So here's the results. As you can see, everything on this line oscillates to an equivalent amount, and when it's all calculated, the total energy is equal to 0 because it's completely oscillatory. Here's the visualization of the oscillation from the object off the spring. And then here we have the x position versus time, where the blue is the computational model. And then the red line is the experimental model. And as you can see, it follows it very closely, except for a few things like here and here where it gets a little off. And again, towards the end, starts becoming less accurate. And then here we have the y position versus time, and then again the blue is the model and the red is the experiment, and it follows it very closely throughout. The only thing is that the peaks of the experiment oscillations are a little bit higher throughout, consistently higher. So what if we did not consider gravity in the program? In this case, the values would be far less accurate because we do have to consider the fact that the spring was being pulled down by the weight, and so gravity had to be in effect there. What if the spring had a different stiffness value? In this case, the calculations would all be run the same, but if it were less stiff, the x and y values would vary more, and if it were more stiff, the x and y values would vary less. So what does it mean? So spring forces are non-constant forces, and after everything is calculated and combined, all the forces on the spring equals 0. Thank you.